Welcome to The Explainer. Today, we're diving into a huge shift happening in the world of artificial intelligence. For years, the whole story of AI was digital. It all happened inside servers and on our screens. But that is changing, and it's changing fast. We're going to break down how the AI revolution is literally moving from code into the physical world. We're talking power grids, global strategy, and massive concrete infrastructure. Let's get right into it. For the longest time, the strategy in AI was pretty simple. Just make everything bigger. More data, more parameters, more computing power. But we're now starting to hit some fundamental limits. We're facing a real potential shortage of two things you absolutely can't do without: the electricity to power these beasts and the high-quality data you need to train them.
So, what happens when you can't just throw more resources at the problem? Well, the industry isn't giving up. It's getting strategic. We're seeing this massive shift from a purely digital arms race to one that involves actual concrete, steel, and geopolitics. The age of AI is getting very, very real.
Okay, so first up, let's look at how AI is evolving to be more efficient. The industry is realizing that for a lot of problems, brute force just isn't the answer. Instead, they're coming up with these new ways for AI to think that can solve really complex problems in completely different ways. So, say hello to the energy-based model, or EBM. Now, this is totally different from an LLM that just tries to predict the next word in a sentence. An EBM thinks more like an engineer. You give it a set of rules, a bunch of constraints, and its whole job is to find the best possible solution that breaks the fewest rules. It's a system built for pure, cold logic.
And this is where it gets really interesting. Just look at how stark the difference is. A startup's EBM, called Kona, went head-to-head with the world's most powerful LLMs on solving hard Sudoku puzzles, and the results are just staggering. Kona solved over 96% of them in milliseconds for a total cost of about $4. The giant LLMs, they barely solved 2%, took forever to do it, and racked up an estimated bill of $11,000.
This right here is the perfect example of a really crucial point. For problems that have clear rules and logic, things like optimizing a power grid, designing a microchip, or figuring out complex logistics, these specialized, super efficient models could absolutely demolish the general-purpose language models we always hear about. This is a potential game changer for critical industries. And this whole smarter approach is also changing physical science. Take the race to build better batteries. There's a new framework called discovery learning, and what it does is combine our knowledge of physics with real-world test data. Then it intelligently figures out which new experiments to run next. It's like a super fast, super smart research assistant. The impact of this is just wild. By using this AI-driven approach, researchers think they can predict a battery's lifespan with 98% less testing time. Think about that. What used to take years of painstaking work in a lab could now, maybe, be done in just a few weeks. This is AI just collapsing R&D cycles in the real world.
But smarter models are only one side of the coin. The other side is a brute force investment in physical infrastructure on a scale we have literally never seen before. Because even the smartest AI in the world needs a truly staggering amount of power.
The AI boom isn't just a tech company thing anymore. Legacy industrial giants like Siemens Energy are now pumping $1 billion into expanding manufacturing for grid hardware. And they're saying it outright. The demand is coming from AI data centers. AI's growth is now physically tied to the capacity of our power grid.
And that demand is kicking off a massive global spending spree. Projections show data center spending jumping from $500 billion to over $650 billion in just 1 year. That's a nearly 32% increase, an absolutely colossal figure, driven almost entirely by the race for AI dominance.
The scale of these projects is almost hard to wrap your head around. Over in the UAE, there's a planned data center called Stargate that's being designed to use 5 gigawatts of power. To put that in perspective, that's the kind of output you get from several large nuclear power plants, all of it dedicated to a single AI facility. It's insane.
And this really gets to the core of the new AI strategy. The competitive advantage, the moat that protects a company's lead, it's not just about having the best algorithm or the most data anymore. The new moats are physical things, having access to massive amounts of energy, controlling data pipelines, and flat out owning the underlying infrastructure. So let's see how this infrastructure race is morphing into a global competition. Because when physical assets and energy become the keys to AI, the game stops being just between companies. It becomes a global geopolitical struggle between entire nations. I mean, just look at Elon Musk's recent move to bring XAI under the same roof as SpaceX. This creates a completely unique, vertically integrated system. He now controls the rockets to launch the satellites, the global satellite network to distribute the data, and the AI models themselves. It is a fully integrated system that connects the algorithm in the data center directly to orbit.
At the exact same time, we're seeing this global chess game being played with the most critical components, especially those high-end chips. The fact that NVIDIA's advanced H200 chips are flowing back into China shows that export controls are this constantly shifting lever of power. Access to raw computing hardware is now a central piece of foreign policy.
And the amount of money being thrown around is just mind-boggling. There are reports that a coalition of tech giants, NVIDIA, Microsoft, Amazon, are negotiating a potential investment of up to $60 billion into OpenAI. A move like that would concentrate the world's frontier AI power into a tiny handful of allied corporations. So, what does this monumental shift from digital code to physical concrete actually mean for all of us? Well, it means that as AI gets deeply woven into our critical infrastructure, our power grids, our supply chains, our defense systems, the stakes get exponentially higher. Security becomes absolutely everything. And with that, a whole new class of threat is starting to emerge. Researchers are now actively trying to fight against something they call sleeper agent AI models. These are models that can pass all the normal safety tests, but they have hidden, malicious code inside that can be activated by a secret trigger, like a specific word, a date, or an image.
Here's how it could work. An organization downloads a powerful open-source model that seems totally safe, but hidden deep inside, there's a back door. When the model sees a secret trigger, it could just abandon its normal task and instead execute a malicious command, like, say, shutting down a power grid or stealing sensitive data. This makes model security a top priority for everyone.
Look, the big takeaway here is this. The story of AI is no longer just for tech blogs and research papers. It's now a story about industrial policy, about national security, and about the real-world competition for physical resources. The conversation has fundamentally and permanently changed. And that leaves us with one last really provocative question. As this new reality takes shape, the future of AI won't be decided just by the cleverest coders. It'll be decided by whoever controls the physical levers of power. The question for all of us is, who do you think those people will be?